Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So now here we have been provided with a square prism of 40 millimeter edge of the base and axis height 60 millimeter. So this square prism, it stands on its base onto the horizontal plane with all the vertical faces of the square prism happen to be inclined at an angle of 45 degree with respect to the vertical plane. So let us first of all evaluate the orientation of the square prism with respect to the two reference planes over here. So if we locate the square prism onto the horizontal plane into this orientation, so two of the edges or the vertical faces of the square prism, they will be parallel to the vertical plane, and two of the vertical faces of the square prism will be perpendicular to the vertical plane. So we are not going to get all the vertical faces inclined at an angle of 45 degree with respect to the vertical plane over here. So this is the incorrect orientation of the square prism with respect to the two reference planes. Now if we locate the square prism into this orientation onto the horizontal plane, now we will observe that all the four vertical faces of the square prism, they will happen to be inclined at an angle of 45 degree with respect to the vertical plane. So this is the correct orientation of the square prism with respect to the two reference planes over here. So now we have been provided with the information that a square hole of 40 millimeter diameter, it is drilled centrally through the prism over here, such that this hole, it should pass through both the opposite vertical edges of the prism over here. That is, the hole passes through and through this particular square prism in such a way that it is going to intersect these two front vertical faces and these two back side or rear side vertical faces of the square prism. So we are going to get through and through drilling of the square prism into this orientation with a horizontal hole of 40 millimeter diameter. Now this hole will be drilled such that the axis of this hole, it will be perpendicular to the vertical plane over here. So with this information, we are required to obtain the development of the lateral surfaces of the square prism over here. Let us first of all evaluate the orthographic construction of the front view and the top view projections of the square prism over here. So to begin with, we are going to start with construction of orthographic top view projections of the square prism. So now here we have oriented the square prism onto the horizontal plane in such a way that all the vertical faces or the vertical edges of the base, they will be inclined with respect to vertical plane at an angle of inclination of 45 degree over here. So now we know that edge of the base, it happens to be 40 millimeter. So once the observer is going to look at the square prism from the top, so we are going to obtain the square projections into this orientation drawn onto the horizontal plane over here. So now we have marked all the 4 points of the base A1, B1, C1 and D1 into the top view projections over here, and these 4 points, they have been marked on the inner side of the top view square projections of this prism over here. Similarly, the 4 points corresponding to the top face, that is A, B, C and D, they have been marked outside the top view projections of the square prism over here. Now once we have obtained the top view projections corresponding to the base and the top face of the square prism, now let us obtain the access points of the square prism. So here we have been able to join the diagonals A1, C1 and B1, D1 over here. So wherever the two diagonals of the prism they are going to join, will be obtaining the access point corresponding to the square prism. So now we are going to obtain the front view projections corresponding to the square prism over here. So we know that the access height of this prism happens to be 60 millimeter. So now once we mark the height of the prism or the access height of the prism equal to 60 millimeter, now we can obtain the front view projections corresponding to the square prism over here. So now we have obtained 4 points A1 dash, B1 dash, C1 dash and D1 dash corresponding to the base of the square prism onto the XY reference line. Now 4 points corresponding to the top face, that is A dash, B dash, C dash and D dash, they have been obtained at a height of 60 millimeter above the XY reference line over here. Why? Because the height of the square prism happens to be equal to 60 millimeter over here. So now we know that in this front view projections, so we haven't darkened these vertical edges, that is B dash, B1 dash and D dash, D1 dash over here, while we have darkened the outer edges of the square prism over here. So the reason behind this is because this prism is going to be cut by a section plane which will be circular in nature. That is, we are going to drill a hole through and through both of the front two faces and through the rear two faces of the square prism over here. So that is why the vertical edges BB1 and DD1, they will be intersected by the square hole over here. So that is why we haven't joined B dash, B1 dash and D1 dash using the darker object line over here. Another thing we need to remember over here, that the vertical edge DD1 which is lying on the rear side of the solid, so it is going to be superimposed by the vertical edge BB1 which is available with us in the front side of the solid. So we should obtain the hidden line projections, that is the dotted line projections corresponding to the rear side vertical edge D dash, D1 dash over here. But we are not able to see any hidden line projections into the front view projections. Why? Because the hidden line projections corresponding to the vertical edge D dash, D1 dash, they have been superimposed by or the overlapped by the object line projections corresponding to the vertical edge B dash, B1 dash over here, which is appearing on the front side of the square prism. So now we have obtained the front view projections of the square prism. We have been able to obtain the top view projections of the square prism, which happens to be inclined with respect to vertical plane at an angle of 45 degree. Now we know that there is a central hole which we need to obtain over here, and this hole should be obtained at a height of 30 millimeter. That is, the access height is 60 millimeter. So from the top face, we have marked the center point of the circular hole over here at a distance of 30 millimeter from the top face or 30 millimeter from the bottom face. Now we know that this hole is going to have the diameter equal to 40 millimeter. So now with a radius of 20 millimeter, from this center point, we have marked this hole which we are going to obtain onto the front two faces and onto the rear two faces of the square prism over here. That is, through and through, this hole should be passing through all the inclined faces of the square prism over here. So now we can divide this hole into 12 equal parts. So we can check this hole which we have obtained corresponding to the radius 20 millimeter or diameter 40 millimeter. So this we have divided into 12 equal sectors over here, such that the included angle for each one of these sectors, it should be equal to 30 degree over here. So all these 12 points corresponding to the circular hole into the front view projections we have marked over here in the elevation projection view. And now we can see that these are the vertical edges which have not been intersected or cut by the circular hole. So this portion of the vertical edge BB1 and DD1, so we have been able to join over here. So now we have been able to obtain the front view projections corresponding to the square prism which has been cut by a circular cutting plane over here, or a horizontal hole of 40 millimeter diameter has been drilled centrally through the prism over here. Now we see that into this particular case, so the 12 points corresponding to the circular hole we have obtained into the front view projections. Now let us see, whenever we are going to drill a hole over here, now this hole should be passing through all the 4 inclined faces of the square prism. So let us now evaluate the corresponding points of this hole which we are going to obtain into the top view projections onto these inclined surfaces of the square prism over here. So if we bring a vertical projector through the point 1 dash, so we see that this point of intersection will be obtained alongside this edge, that is AD or A1 D1 over here, onto this face AA1 and DD1 over here. So this point 1 will be located at this much distance from point A over here. Similarly, point of intersection 1 will also be available onto this face in the top view projection, that is AA1, B1 and B over here. So this inclined face, it will also be intersected by this circular hole over here. So the point 1 will be obtained at a distance of this much from the end A towards the end B over here. So the location of point 1 onto the boundary or the edge view we have obtained onto the top view projections over here. Similarly, the 2 points 2 dash and 12 dash, they are also going to lie onto one vertical line when the observer is going to look at the solid from the top. So the points 2 dash and 12 dash, they will be overlapping with each other. So onto the rear face alongside AD, these 2 points 2 and 12, they will be available at this distance alongside the face AA1 and DD1 over here. Similarly, onto this face AA1 and BB1, so at a distance of A to 12, so we are going to evaluate this distance alongside the dimension AB over here. So these 2 points of intersection, they will be available over here. So the next 2 points of intersection 3 dash and 11 dash. So when we are going to look at these 2 points of intersection from the top, so we will be observing that these 2 points, they have coincided with each other in the top view projections. So the points 3, 11, they will be available alongside this edge AD at a distance of A, and 3, 11, that is on the rear side of this particular solid. Similarly, onto the front side of the solid alongside this edge, we are going to measure this distance over here. Distance from point A to 3, 11 alongside the boundary of the solid as we are going to move from point A to point B over here. Next 2 points of intersection, they happen to be 4 dash and 10 dash. So when we look at these 2 points of intersection from the top, so the points 4 dash and 10 dash, again they will be converging with each other or coinciding with each other, and they will be available on the vertical edge, that is DD1, and they will be available onto the vertical edge BB1 over here. So this way points 410 will be available onto the vertical edges DD1 and BB1 over here. So we have marked these 2 points over here at these 2 corners of the square prism. Now the next 2 points of intersection, they happen to be phi dash and 9 dash. So points phi dash and 9 dash, again, when we look at these points from the top, so these 2 points of intersection, they are going to converge with each other, and on the rear side these 2 points will be available at this distance, that is distance between point C and 5, 9 alongside the boundary of this particular square prism, as we are going to move from point C to point D over here. Similarly, onto the front side, these 2 points 5 and 9, they will be available onto this vertical face over here at a distance of B259, as we are going to move along B2C over here. Next 2 points of intersection, they happen to be 6 dash and 8 dash. Once we are going to look at these 2 points from the top, so we observe that these 2 points of intersection, they have also coincided with each other in the top view projections, and onto the rear face we are going to observe the location of the points 6 and 8 alongside the rear edge CD over here at a distance of C268 over here. So we'll measure this distance on the rear side. So we'll be able to locate the points of intersection 6 and 8 onto the vertical projector, which will be at this distance from point C over here. Similarly, onto the front side, so we will observe that point 6 and 8, they will be located over here. So as we are going to move from point B to point C alongside this particular edge BC over here, so at a distance of B268, so we'll measure this distance, and the vertical projector corresponding to the points of intersection 6 and 8 will be located accordingly. And finally, this last point is 7 dash. So as we look at this point of intersection from the top, so point 7 dash will be projected onto the rear side at this location. That is, as we move from the corner C to corner D alongside this edge CD, so at a distance of C27, so at this distance on the rear side, we'll be able to locate the vertical projector onto which point 7 will be located over here. Similarly, on the front face, point 7 dash will be projected over here. That is, as we move from point B to point C over here, now at a distance of point B to point 7 over here. So we'll be measuring this distance, and from this distance alongside the boundary of the solid, if we move along, then from this distance corresponding to point 7, a vertical projector will be drawn onto which point of intersection 7 will be located over here. So this way, onto the lateral surface boundary of the square prism, we have been able to locate the location of all of these 12 points in the front side. We have been able to locate and identify location of all of these 12 points onto the rear side. Why? Because this hole has to be drilled through and throughout the square prism over here. So it is going to intersect with the front faces of the square prism. The square hole is going to intersect with rear faces of the square prism. So to begin with, we have to obtain the development of the lateral surface of the square prism. As we already know, we have to use the method of parallel line development method in order to obtain the development of the square prism. So corresponding to the top face, one horizontal projector we have drawn over here. Corresponding to the bottom face or the base of the square prism, another horizontal projector we have drawn. So between these two horizontal projectors, we are going to obtain the true length of the height of the square prism. So true length of the height is available, that is 60 millimeter, and the true length of the edge of the base is also available, that is 40 millimeter. So now for rectangular segments now we are going to obtain. We can check A1, B1, C1, D1 and A1. So these four vertical projectors will be obtaining over here at a distance of 40 millimeter from each other. So distance between A1 and B1 will be 40. Distance between B1 and C1 will be 40. Distance between C1 and D1 will be 40. And distance between D1 and A1 will also be 40. Now we are going to measure all these distances of the points of intersection which we have obtained onto the boundary of the square prism as we move along points A to B, B to C, C to D and then D to A. So we can check A to B, B to C, C to D and then D to A. So as we move along A to B, we can check point 1 is located at this distance, points 2 and 12 they are located at this distance, points 3 and 11 they are located at this distance, and points 4 and 10 they have coincided with point B over here. So we can check same distances we have marked over here, point 1, point 2 12, point 3 11, point 4 10. 4 10 is going to coincide with B1. Now as we move along B to C, we can check from B point as we move towards the point C. So first 2 points of intersection which will be encountered, they are 5 9. So we'll measure this distance of 5 9 from point B. We'll measure the distance of 6 8 from B. We'll measure the distance of 0.7 from B. So same way 5 9, 6 8 and 7 points they have been obtained. As we move from point C to point D, so we'll see that first point encountered is 0.7 at this distance, 0.68 will be obtained at this distance, 0.59 will be obtained at this distance, and 4 and 10 they will be coinciding with point D over here. So accordingly we can check same distances we have marked over here. C to 7 it will be the same distance, C to 68, C to 59 and then 4 and 10 they have coincided with point D over here. Now as we move from point D to point A, so the points which are encountered they are 311 at this distance, 212 at this distance and 0.1 at this distance over here from point D. So similarly 311, 212 and 0.1. So all these points they have been marked alongside the boundary as we move from A to B, B to C, C to D and D to A. Now vertical projectors we have drawn through all of these points which we had obtained onto the front face as well as points which we had obtained onto the rear face of the square prism. So now we have been able to obtain vertical projector locus lines corresponding to all of these points of intersections in the lateral surface view. Now the height corresponding to these 12 points we are going to obtain from the front view projections over here. So alongside lateral surface where these points they are lying we have identified over here. On the front side we are going to obtain at what height these points they are going to lie with respect to the horizontal plane over here. So now once we draw the horizontal projectors through all of these 12 points which are available with us corresponding to the circular hole which is visible to us into the front view projections. So the height of all of these 12 points we are going to obtain into this lateral surface development view onto the corresponding vertical projector lines corresponding to the 12 points we have marked in the front face orientation, 12 points which we have marked in the rear view orientation over here. So let us find out corresponding points of intersections of all of these POIs which we have obtained into the front view projections over here. Now we can see we'll start from point 1 dash over here. So this is the height of point 1 dash from the XY reference line. So if we draw a horizontal projector line through the point 1 dash, now wherever this horizontal projector from 1 dash, it is going to intersect with the vertical projector line 1 over here in the lateral surface view. So we can check, this is the vertical projector line corresponding to POI 1. This is vertical projector line corresponding to POI 1. So here elliptical projections we are going to obtain corresponding to the circular hole which is available with us in the front face over here, into the front face projections over here. Whereas onto this side we are going to obtain the elliptical projections corresponding to the circular hole for all of the points of intersections which are available onto the rear side faces of the square prism. So point 1 has been located on the POI vertical projector lines which are emerging from the points 1 over here. Now the next 2 points which are available, they are 2 and 12. So we can check, there are 2 vertical projector lines which we have obtained corresponding to front face, corresponding to rear face, where points 2 and 12 they will be located. So the vertical projector lines, they will provide us the location of these 2 points into the vertical orientation. Now let us find out the height corresponding to the points 2 and 12. So we know that this is the location of the point 2 dash in the front view. This is the location of the point 12 dash in the front view. So if we draw 2 horizontal projector lines through 2 dash and 12 dash, so wherever these 2 projector lines, they are going to intersect with vertical projector lines corresponding to 2 and 12. So the 2 points you can check, we have been able to obtain in the front face projections. 2 points we have been able to obtain onto the rear face projections over here. Now the next 2 points, they are 3 and 11 over here, corresponding to front face. This is the vertical projector. Corresponding to the rear face, this is the vertical projector. Now let us work out the front view projections corresponding to 3 dash and 11 dash. So now once we draw horizontal projectors through the points 3 dash and 11 dash, so wherever these 2 horizontal projectors, they are going to intersect with vertical projectors 311 in the front face and 311 onto the rear face. So the 4 points of intersection, 2 on the front face corresponding to 311, 2 onto the rear face corresponding to 311, they will be evaluated. Now the next 2 points of intersection, they happen to be 4 and 10. So 4 and 10, they have coincided with B1 and D1 respectively. B1 in the front face, D1 onto the rear face. So let us evaluate the heights of these 2 points in the front view projection over here. This is the height of point 10 dash. This is the height of point 4 dash. So from 4 dash and 10 dash, once we draw the horizontal projectors into the developed surface view, now wherever these 2 horizontal projectors, they intersect with vertical projectors 410 in the front face and 410 in the rear face. So the 4 points 4 and 10 in the front face, 4 and 10 onto the rear face projections we are going to obtain over here. Now the next 2 points, they happen to be 5 and 9. So now the vertical projectors through 5 and 9 we have already obtained. This is the vertical projector corresponding to 5, 9 onto the front face. This is the vertical projector for the point 5, 9 onto the rear face over here between C and D. It is this point. So now we know the height of point 9 dash in the front view projection over here. We also know the height of point 5 dash in the front view elevation projection view over here. So from 5 dash and 9 dash over here, if we draw the horizontal projectors, wherever they are intersecting with vertical projector 5, 9 in the front face, vertical projector 5, 9 onto the rear face over here. So the points of intersection will provide us with the location of the points 5 and 9 into the front face projections and 5 and 9 into the rear face projections over here. Next we have got the points 6 dash and 8 dash in the front view projections, and the corresponding vertical projectors, they happen to be lying over here. This 6, 8 vertical projection it is corresponding to the front face projection over here. This 6/8 projection, it happens to be corresponding to the rear face projection over here. So wherever the two horizontal projector lines drawn through the point 6 dash and 8 dash, they are going to intersect with vertical projector lines 6/8 in the front face and 6/8 onto the rear face. So the 4 points of intersection we are able to obtain. So this is the projection of point 6/8 in the front face projection. This is the projection of point 6 and 8 onto the rear face projection over here. And finally the last point is 7 dash. So here we have got vertical projector through point 7 in the front face. This is the vertical projector for point 7 onto the rear face. So onto these two vertical projectors emerging corresponding to the point number 7, wherever this horizontal projector drawn through point 7 dash, it will be intersecting over here and over here. So the 2.7 corresponding to the front face and corresponding to the rear face, they have been obtained. So now we can check 12 points corresponding to the circular hole which are appearing like an ellipse into the front face projection, they have been obtained. Similarly, the 12 points corresponding to the circular hole which is passing through the rear face of the square prism, they have been obtained over here. So now we know that this edge C dash and C1 dash has not been cut by the circular hole. So now we can join these 2 points over here, C and C1, using object line. And then the boundary also we have been able to join over here. And now we know that this portion of the edge B dash B1 dash and this portion of the edge B dash B1 dash, this has not been intersected by the cutting plane. So now we need to join this portion and this portion. Similarly, corresponding to the vertical edge D dash and D1 dash, so this portion has not been cut and this portion has not been cut. So now we are going to join these two portions of the developed surface over here. So now, using the principles of parallel line development method, we have been able to obtain the development of the square prism when the square prism is having all the 4 vertical faces inclined at an angle of 45 degrees with respect to the vertical plane, and there is a circular hole which has been drilled centrally through this particular square prism, and the diameter of this hole happens to be equal to 40 millimeter. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how do we evaluate the development of the truncated square prism which has been intersected by a circular cutting plane over here. So we are going to continue with further discussion regarding few more illustrative cases of development of the surfaces of the solids in the coming lectures. Thank you very much. Thanks a lot.